Okay, Algebra 1, Lesson 1. I'm going to write a little bigger and erase more. Okay, so this is going to be mostly review. Okay, this is going to be mostly review for you guys. The whole first, this is how math works, where you do like a math class and then the next class starts like right here. So it overlaps content. So if you were starting to struggle at the end of your last math class, you're okay, because we're basically reviewing last year's math in the first half of this year. That's just how math works. It's building blocks. So the first quarter anyway is wanting to make sure that you guys are good and strong with your math concepts before we start piling on new stuff, okay? So, oh, by the way, we're right across from the music room. So we'll have music while we do math. So it's the beginning of the year, so it may not be as good as the end of the year, but we'll see. I haven't really thought that through a lot. It's going to be challenging, but it'll be good. Okay, so we're going to just review probably one of my favorite things, adding and subtracting fractions. Okay, and here's what you'll come to realize in math, now that you're progressing more in math. The easier concepts like adding and subtracting will be the more annoying / confusing concepts. And like multiplying and dividing is so much more simpler when you get to algebra and above, because the rules for adding and subtracting are more specific. What's the one rule, the most important thing when you're adding or subtracting a fraction? The what?
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 What? What do you need? Hope? You need hope. Yeah. Yeah, you need a common denominator. Okay, so if you have a common denominator, so let's just remind us of that. Must have common denominator. This is one of those things that you lose in the summer sometimes. Must have common denominator. Okay? If you don't, you can't add them. You can't add apples and oranges. I mean, you could, but it would be a weird mutation of fruit. So if you have common denominators, then you can do it. So what's 5/11ths plus 2/11ths? 7/11ths. Oh, I didn't know that was going to happen. Now I want a Slurpee. Okay, so think of the denominator as like labels. What's 5 apples plus 2 apples? Well, 7 apples. It's not 7 apples. It's just 7 apples. So these guys don't add. These are more of what you're adding. You're adding 5 of those things plus 2 of those things, okay? All right, so if you don't have a common denominator, 1/3 plus 2/5, I'm gonna just write this down, does not equal 3/8. This is a rookie mistake, right? This is what happens after a long summer / quarantine. So I guarantee you, probably my pre-algebra students, remember pre-algebra?
Yeah.
Good times. They're gonna do this, okay? Because it's been a long time since they've added fractions, and that's okay, it's understandable. But you guys are past that, right? So we need a common denominator, okay? So, any suggestions? What do you guys do when you find a common denominator? Pence? You don't like pence? I love Pence. That's a cool name. Okay. Sorry.
Find multiples of both the bottom numbers.
Okay. So multiples are what they go into. So you could do something like this. What? 3, 6, 9, 12, 15, 18, and on and on. Or you could just remember and just stop when you get to your common denominator, right? So we got we have to change these. So here's what I like to do when I add fractions. I like to add them vertically. And that way I can find my common denominator, which is 15. And then the golden rule for fractions, remember, whatever you do to the bottom, you have to do to the top. Whatever you do to the denominator, you have to do to the numerator. So how do you turn that 3 into a 15? What do you have to multiply by? Are you doing this like a 5? Okay. So times 5. So whatever you do to the bottom, do to the top. Times 5 times 5. So 1 times 5 is 5. This is 3. So 3, 2 times 3 is 6. Add them together now because they're common denominators for 11/15. And that's very satisfying. Whenever you finish a problem, especially in algebra, because sometimes they're a little bit longer and you have to figure it out. It's like a puzzle. It's very satisfying to get that final answer. It's nice. Okay, same thing is true with subtraction. Your book is going to list the problems horizontally, and you can add them horizontally if you want, but see how it's kind of annoying? It's just nice because it lays out what you're multiplying by if you need to show your work like that. Most of you will end up doing this in your head anyway, but it's nice to write it out. You could do it like this. Okay, so that's 3 times 5. 1 times 5 is 5. 5 times 3, so 2 times 3. See how that gets real messy real quick? So, but you could do that if you wanted to. You don't have to do it vertically, but I would encourage you to do that. So what's 2/3 minus 1/8? First step is what? Yes. Right, common denom. That's a cool way to say it. Try it. Say it. Common denom. Yeah, awesome. So what's the common denom of 3 and 8? Yeah. 24. A lot of times it's just the product of 3 and 8 when you multiply it together. So in this case it's 24. So how do you rewrite 2/3 with the denominator of 24? What's the numerator going to be? No. What? 16. Right, because 3 times 8 is 24, so 2 times 8 is 16. Is that making sense? You guys, is this coming back to you? Okay, 8 times 3, 1 times 3. So now we're subtracting. 16 minus 3 is 13, 24ths. You can always check to see if you can reduce it. Nothing goes into both the top and the bottom, so you're good, you're done, you're happy. It's awesome. All right, so that's adding and subtracting just simple fractions, okay? Now what makes it not simple is when you get mixed numbers in there and things like that. So let's try a couple examples. 13 and 2/5 plus 2 and 1/8. Same rules apply. What's the common denominator of 8 and 5? I saw some lips go together. Yeah, 40. That's right. So how do you turn that 8 into a 40? Yeah, again, a lot of times it's just multiplying those two together. Okay, so 1 times 5 is 5. 5 times 8, 2 times 8. So now you can still add them together. You get 21/40ths. So just like when you're adding multiple digit numbers, you just start on the right side and you go left. So we started on the right side, the fraction part of the number. Now we go left. 13 plus 2 is 15, and there's your answer. Okay. Now that was nice because you didn't have to carry anything, or you didn't end up with an improper fraction where there's a whole number in there that we have to bring over to the whole number side. So let's do one like that. Let's try 13 and 3/5 minus, we'll subtract. Well, let's add first, just because we can. 2 and 7/8. Okay, still the same common denominator is 40. 40, this is times 8. This is times 5. So when you add those together, you get 59/40. Oh, here's another rule for you newbies here for my class. What happens when you correct, if I make a mistake and you correct it?
Oh, you get a free problem set.
Yes, then I will give you a free problem set. That means you don't have to do one of your problem sets, okay?
Not Flack text.
What's that?
I'm still using Flack text.
Flack tax, yeah, that might be tough. Again, like the whole at-home thing. But I did have a couple students correct my mistakes when I was making those videos during quarantine. A couple people corrected my mistakes, so I gave them like extra credit and things like that. So make sure you're paying attention. This is another great reason to pay attention, because if you can skip a problem set, that's like an hour of your life, which is pretty good. And if like minimum wage, what's minimum wage these days?
$12.
Yeah, so $12, like that's an hour of your life where you could have been working or something. So when you correct a mistake, you just got $12. Think about it. It's exciting. All right, so we're gonna just finish this real quick. 13 plus 2 is 15. Now this is a right answer. That's a right answer, but it's not written in the proper format, okay? Like what time is it? It's 7:118 a.m., right? Because I could say this is 7:118. That's what time it is. Oh, well, it's also 8:58. But what's 58 plus 60? So this is still the 7 hours in the morning plus 118 minutes. This is the right time, and it's really fun to tell time that way. But this is the better format. Okay, so there's a whole number in here. There's a whole number. When you take 40/40ths out, you're left with, what is that, 19/40ths?
Yep.
So that
16 and 19.
Yep, so that 1 gets carried on to the whole number, so you get 16 and 19/40ths. All right, we're gonna continue this next week. All right, well, let's keep going. So we started talking about adding and subtracting fractions, then we got to some mixed numbers. So yeah, let's try another example here. So I think we ended with something like this: 13 3/5 plus 2 7/8. So remember we have to find a common denominator, which was 40, we decided. Whatever you do to the bottom to get to 40 times 5, do to the top. 5 times 8, 3 times 8. When you add them together, you get 59/40ths. And then when you add those, you get 15. Okay? That's technically right, we said, but it's not grammatically correct. It's not in the right format. So first you have to change that to a mixed number. Okay? The quick and easy way is to just figure out how many times 40 goes into 59, which is most of the time 1. When you're doing these problems, it's most of the time it's just 1. So really it's just, you're just gonna add 1, and then whatever's left over is 19. But if you wanna write it out, you can do that. 59 divided by 40, because this is just a division problem. Remember, fractions are just division problems. This guy divided by that guy. So it goes in 1 time. Dirty monkey smell bad. Dirty, divide, multiply, subtract, and then you're done. So your remainder goes on top like that. So it's technically 15 and 1 and 19/40ths, right? Well, 15 and 1 is just 16. Okay, does that feel all right? All right, so you're gonna get some of those in your homework. The other thing that you're gonna get is subtraction. And there's a couple different ways we can do this. We're gonna try both and see which one works for you. You can try it either way. You can do it either way you want. Or if you have another way that I don't know about, you can do that as well. Actually, I'm gonna show you 3 ways because this will be good. This will be good. Okay, still the same rule applies. You have to find a common denominator. So 40, and these are the same fractions, so that makes it easy. 24, 35. So now this time we're subtracting. But what's the problem with subtracting now?
There's not enough to subtract.
Right, there's not enough to subtract. So normally, what do you do when there's not enough in this column to subtract? What do?
Don't you take one of the whole numbers?
You borrow. So you're going to take a whole number and you're going to put it here. A common mistake is to put a little 1 there because that's kind of what we're used to, right? Oh yeah, you cross out that number and then put a little 1 next to that one. Well, the reason why you put a little 1 next to that because you're basically adding 10. Well, you're not adding 10, you're adding 1. You're adding 1 whole. So borrow a big 1 and put a big 1 there. So this is just, well, let's figure that out. 40, you guys remember how to change a mixed number to an improper fraction, the little circle trick? But really, 1 is just, how many 40ths is 1 whole? If you had a pizza with 40 pieces, how many 40ths is 1 whole pizza?
What?
40, right. 40, yeah, pizza with 40 pieces. That's a lot of pizza. But it's going to be really small pieces, so it doesn't really taste good. Yeah.
It might be the same size as a regular pizza. It's just
Yeah, if it's the same size of a regular pizza, then your slices are going to be really thin. And in my experience, the bigger the piece is, the better it tastes. Okay, so science. Are you doubting me? Okay, you look like you're doubting me. It's real, it's science. Okay, so that's just 40 40ths plus another 24 40ths. That's 64 40ths. Okay, so now we can subtract. Because 13 and 24 40ths is the same thing as 12 and 64 40ths. Okay? So subtract, what is that? 29? Okay, and then subtract over here and you're done. So that's one way to do it. If the whole borrowing thing confuses you, well, you can do it this way too. You could, if we're at this point, I'm going to say or 13 and 24 40ths minus 2 and 35 40ths. So if you're here and you say, okay, I think I forgot the whole borrowing thing. I know how to borrow with normal numbers, but fractions, it confuses me. You can always just change these to improper fraction. So you can just multiply 40 times 13, which is 420, plus 24 is 444 40ths. And then do the same thing, 80 plus 35 is 115 40ths. When you subtract, you get 329 40ths. And then if you change that back to a mixed number, how do you do that? Well, you just divide. That goes in what, like 9-ish times, 8-ish times, I think 8-ish times. No, it shouldn't be. I did something wrong. So this is where you would get a free problem set if you correct. Oh, this is 520 plus, so that's 544. So if you notice me making a mistake and you catch me, then you get a free problem set. Did we talk about that?
Yeah.
So, but you guys know the new Flack mathers. So if you correct a mistake nicely, don't say, Mr. Flack, you screwed up. Why do you even work here? Don't say that, okay? But if you say, hey, isn't that 544? Then you get a free problem set. So, all right, how many times is 40 going to 429? That's much easier. That's like 10. So, blah, 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 blah. Okay, so 10 and 29 40th. Same answer. So most of you are thinking, okay, that looked like a lot of big numbers and a lot of math, so I'm going to try to make this work, okay? And that's okay too. Another thing you could do is, this is the third method, and you don't have to do this if you don't want to, but let's start over here. 12 3/5 minus 2 7/8. Well, if that was just, is it not 2 7/8?
13.
Oh, 13, got it. Is that a math mistake? Or am I just copying the problem down wrong?
I think you're just wrong down.
Okay, well, I'm gonna give you half of a point. So if you correct me on another, like, Mr. Flack, you're purposely confusing us, then I'll give you a free problem set.
Okay.
I should just give you a free problem set. Should I?
I don't know.
Yeah, I think I should. Because that's confusing. All right, so here's another method. And I learned this from Steve Demi. Anyone know who Steve Demi is? No one's ever done Math UC? You know Steve? I love that guy.
That was his name.
Yeah, I know his name. He doesn't know my name, but I know his name. He's my hero. Okay, so 2 7/8. If that was just 3, if it was just 13 and a fraction minus like 3, the whole number, then you just take away 3 from the whole number. You don't even have to worry about the fractions, right? Well, let's just make it 3, because you can add whatever you want to both parts of the subtraction problem. What's 10 minus 8? 2. What's 11 minus 9? 2. What's 12 minus 10? It's the same subtraction problem, right? What I'm doing is I'm adding the same thing to both the top number and the bottom number. Okay, so that's what I'm going to do here. But first I'm going to get a common denominator. So this is still 24/40 and 35/40. Well, if I just added 5 more 40ths to this, look what happens. Plus 5/40 plus 5/40. I get 29/40. And then I get 0. I get nothing here. But what happens is I add 1 to this. So then this becomes 40/40. Well, 2 and 40/40 is just 3. So then it's just 13. So then it becomes 13 and 29/40 minus 3. Well, look at that. What's that? That's just 10 and 29/40. Now, I made it a little overcomplicated, but basically once you're at this place right here, where am I? 13 and 29/40. Oh wait, 13 and 24/40. And 2 and minus 2 and 35/40. Well, here's what you can do. Okay, I just need to add 5/40 to both of those. So I'm going to do this. I'm going to make that 29. I'm going to get rid of that completely and make that into a 3. So now it's 13 minus 3, which is 10. 29/40. You basically just rewrite this top fraction and you're done. Okay, that's another way to do it. That might be a little complicated, but it might save you some time as well. So there's 3 options. You can choose one of them. You can try all 3 of them, because you'll have problems like this in your problem sets, and see which one you have the most success with and see which one is easier to remember or whatever. Okay? Does that feel all right? Subtraction? Okay, let's switch gears, because Saxon does that a lot. For those of you who don't know Saxon very well, Saxon is what we call a spiral curriculum. So what it does is it visits a concept, and then it goes to another concept, and then it comes back around and talks about that same concept we talked about a few weeks ago. It's great because it never lets you forget stuff, but your brain almost explodes by the end of the year. Okay? But Saxon does a good job of helping you retain the information. Lots of other math curriculums go from one subject to the other, and then at the end of the year, you're supposed to remember what you learned back in August. And that's hard. But Saxon, even though it's kind of brutal, toward the end of the year is great at forcing you to remember stuff. Okay, but the gear we're going to switch to is geometry. Now this is real easy geometry. You guys, most of you guys will be comfortable with this. We're just going to talk about lines and segments. This is still lesson 1. This is part 3. We're going to talk about lines and segments. Okay? All right, so I'm going to draw a line. If I asked your younger sibling to draw a line, what would they do? They just go like that. But in geometry, how do we draw a line? What do we need?
An angle.
Nathan?
Arrows?
Arrows, because what is technically in geometry, what's this? That's a segment, it's part of a line. But a line goes forever in both directions. So when you draw a line in geometry, you have to put arrows on both ends, okay? So let's say there's 3 points. Well, actually, how many points are on a line? Anyone know? There's an infinite number of points. Because it goes on forever, these are all just connected points. I could have drawn this line like this. Right? All the infinite points. And even that, there's still a bunch of points in between all those little points. So technically, that's what drawing with a marker or pencil or pen, what it's doing is it's connecting a bunch of different points. That's all it's doing. So there's an infinite number of points on this line. There's actually an infinite number of points in between these 2 points. I know it's hard to realize that, but just like there's infinitely big, there's infinitely small. This is cool too. This is something I need to ask my brother. Hey, does that open? Okay. All right, don't open it yet. But here's the deal. So your fingers, try to put your fingers as close as you can together, okay, without touching. All right, now see if you can. Do you think you can get closer if you tried? Yeah, I mean, theoretically, you could get twice as close, right? You could cut that distance in half, right? And theoretically, you could cut that distance in half. And theoretically, you could cut that distance in half. So you can get as infinitely small, just like you can get infinitely big. All right, let's open that. Let's see. He's gonna. Mr. Flack? Hi. Hey, so I heard this biology thing. I don't know if it's true or not, but is it biology? Like when you're pressing your fingers together, are you actually touching your fingers, or is it like, I heard some urban myth that you're like, just, what is it, like the pressure of something? Can you speak up so these guys can hear you? He says it's atomic theory.
Depends on what's touching. I mean, the nucleus of the atom aren't touching. It's just something. No.
Okay. So your fingers aren't really touching.
Sure.
Okay. We're gonna go with that. He said it. He's sciencey. So that's a thing. That's like Mr. Flack said it, so it's true.
So when like you press it down,
Yeah,
like,
when
while
you're
still
touching,
not touching?
you're actually not touching your fingers together. Isn't
Okay,
that crazy?
so when I'm like, when I'm playing guitar, okay, let's try.
Yeah.
When I'm playing guitar, I'm not actually touching the
Yeah, it's just the pressure of something. I don't know. But when, so when I punch Elkin in the face, he really can't have me arrested because I never touched him. Okay? So, I'm gonna try that
But
later.
you scared me. Doesn't that count as assault in some
Yeah,
world?
it does.
Maybe in New
It
York?
does.
I don't know.
You can have me arrested. Oh shoot. Oh, it's facing this way, so it didn't actually see me punch. I didn't punch him. I didn't. Technically, I haven't ever touched anybody. Okay. Okay, so what were we talking about? Oh yeah, points. All right, so here's the deal. All you have to do is pick a couple of these points to say what line it is. This is line AC, or the way we could say it, this is how the cool kids are writing it. They put, instead of writing out the word line, they just put AC and a little line symbol on top of it. Now technically that could be CA, right? Because it's just 2 points. It doesn't matter what order you say it in. It's just 2 points. Now since there's another point, if you knew other points, it could be AX or XC or XA or CX. Okay, so there's a bunch of different names for that figure, that geometric figure right there. Okay, does this sound familiar? You guys remember doing this? Okay, so now a line segment, another word for segment is just part of. A line segment is literally, and I can say literally, not like I was literally so upset. You know, I'm not abusing the word literally like so many people do these days. This is literally part of a line because segment means part. See, that's how you use the word literally, okay? Are you guys literally abusers? Do you abuse that word? It's okay. First step is admitting you have a problem, and then I think there's some medication you can take to help you through that. I'm just kidding, there's not. Don't take drugs. No.
What if they're prescribed?
Prescribed literally eliminator drugs? Then
What
yeah.
if they prescribe from a drug dealer?
It's good. Prescribed what?
From a drug dealer.
Oh, yeah, yeah. That's,
Oh, you've got an appointment on Tuesday. Come pick up your drugs.
You never said who it had to be prescribed by.
you're right. I am encouraging some bad behavior. But yeah, I don't know if they make these drugs. They might. I think A West. Better than them, right? Don't say that. Okay. Okay, so let's get back to this before I get arrested. So when you're naming a line segment, so it's not enough to just say 2 points anywhere on the line segment. You have to pick the 2 end points. So if this was M and N, you would say this is line segment or segment MN. Bless you. Line segment MN, or we could write it like this with just a line segment on top, or you could say NM. But what you can't do is pick a point that's not one of the endpoints, okay? So in a line segment, there's no beginning and end, there's just end. Okay, there's 2 endpoints. So we don't say M is the beginning point and N is the end point, okay? That comes a little later. Well, actually it doesn't, even with rays, it just starts with 1 and yeah. Okay, so questions on lines and line segments? All right, so the reason we bring this up is because one of your homework assignments, one of your problems is gonna look something like this. So I'm gonna say segment AC measures, I think, 10 1/4 units. So here's AC. Put a B in there too. So if I was talking about line segment AC, it would be this, right? Okay, if I was talking about line segment AB, it'd be there. line segment BC is right there. So see how there's 3 different line segments that you could name right now because we have 3 points. But all right, so AB or AC measures 10 1/4 units, and BC equals 4 3/7 units. Okay, what does AB measure? Okay, yeah,
You just subtract.
right, good. Okay, so it helps me visually to say, okay, AC is 10 1/4 units. So I'm going to put 10 1/4 from here to here. Got it. Okay, and then BC is 4 3/7. So here is like 4 3/7. So then we want to figure out what this is. Oh, I see. So we just want to take this thing and cut off that much. What's a fancy math word for cut off? Subtract, get rid of. Okay, so let's do that. So we're basically going AC minus BC equals AB. So let's do it. So 10 1/4 minus 4 3/7. Okay, what do we do first?
Common denominator.
Common denominator, what is it? 4 and 7.
28.
28. When in doubt, just multiply them together. And you'll always have a common denominator, but you may not have the least common denominator, but you can always just multiply them together. Okay, so 7 times 4 is 28, 3 times 4 is 12, 4 times 7, 1 times 7. Okay, so you can't subtract 7 minus 12, so what do you want to do? We have 3 ways to do this.
Borrow it.
Borrow.
Or you can make them both improper fractions.
Yep, let's borrow. Okay, but you could say 28 times 10 plus 7, you could do that. So I'm gonna borrow, so this is now 9. So what do I do with that, Elkin?
Subtract them. Or no, multiply it. So add that to the.
Okay, so what am I adding to this?
You're adding the, so it's 1 times 4 plus the 1.
Yeah, except now we're over here, because that was old news. Now we have a common denominator. Yeah, so 28 times 1 plus 7. So that's 35 28ths minus 12 28ths is going to be 23 28ths. So our answer is 5 and 23 28ths units. Is that right? It is. Okay, so the other thing that you're going to come across is you're going to have 2 fractions being subtracted, and then you're going to add a fraction. Just go left to right and do 1 fraction at a time. Yes?
Okay, so can't you, like, when you're trying to find the common denominator, if they're like both under 10, can't you just multiply them together?
If they're both under 10, not necessarily. Like if you want to find the least common denominator, like 6 and 8 are both under 10, but the common denominator is 24, not 48. But yeah, you can always just multiply them together, but just make sure your answer is reduced. A lot of times when you find the least common denominator, that's hard to say early in the morning, denominator, you don't have to worry about, a lot of times, reducing your answer, okay? But if you chose 48 instead of 24, there's nothing wrong with that. You just have to be extra careful about your answer. So whenever there's a fractional answer, you have to make sure it's reduced, all right? Otherwise, I take half off of that because I'm a jerk. No, I'm not. All right, so that's lesson 1.
Flack math! Give me some math and I'll give you some flack. Flack math!